Welcome to this e-lecture, which will be about probability sampling, and that's how to achieve a representative sample which may say something about the population that we want to say something about. So often we want to say something about the population. We want to survey a population to know whether Norwegians are trusting or not trusting compared to the Swedish population or the Kenyan population, and so on and so on. But we cannot survey the whole population, so we want due to the cost. So we want to do a representative sample, What is sampling really all about? Well, it's sampling of units. Sometimes we can study all units, the total population. And in Norway we can do that often because we have registered data. So there's a lot of research questions that can be answered using registered data. Of course, the registered data says nothing about attitudes. So if we want to know anything about attitudes, we need to do a survey. And that's the case for most countries, and most countries do not have registered data, so they have to base their analysis on surveys, and these surveys are often based on samples. So you can just study some units from the population, and that is just a sample. But if we do a sampling of units, we want that sample to be representative. We want it to mirror the population with regard to the distribution of all relevant characteristics, that is, variables in the population. We want it to mirror the population according to sex, education, where people live, what they earn, so on and so on, because all these characteristics may be important for the social phenomenon we want to study. So we want that sample to really mirror the population with regards to these characteristics. And probability sampling is known by equal probability for all units to be a part of that sample. All units have the same probability for being drawn from the population to be a part of the sample, and a known probability for being part of the sample. And it's independent of probabilities. That means that if one unit is drawn from the population to be a part of the sample, it doesn't affect the probability of other units being drawn to be a part of the sample. And if we have this probability sampling, then it's very likely to get a representative sample. Because we remove all systematic sources for sampling error, and we make inferential statistics possible. That is that is generalizing from a sample to the population. And let's look at how this can be illustrated. Probability sampling. We have a population, and from that population we make a sampling frame. And a sampling frame is a list of all units in the population. From that sampling frame we make a random selection, but we can also introduce a mechanism that ensures that various groups will be included. Often we will get a representative sample by making a random selection from the sampling frame. But if we want various groups to be included, we have a specific group we want to study, which may be small, and then we want to be sure that people from a village, for example, in a special part of Norway is represented, or a village in Kenya. We can stratify according to where people live, so we know that people we ensure that we draw some people living from this village, so we stratify according to where people live. Or we can stratify according to sex. If we want if it's half men, half women in the population, we stratify according to sex, for example. And it's a question about sample size. And sample size is a question that depends on the need for statistical precision. larger samples gives more statistical precision. If we want 100% statistical precision, we have to have the whole population in our sample, but then it's not a sample anymore, then it's the total population. But the larger the sample, the more statistical precision. That means that the less it's less uncertainty. The estimates that we make are less uncertain, in the sense that if we do estimations on smaller sample, these estimations will be more uncertain. For example, an estimation on the trust level in Norway, if it's a very small sample, it's more. It will be more. It will not. Our estimation of the level of trust will be less precise, so to speak. It's more uncertainty about if that's the right estimate, or if that's a true level of trust or not. But the larger the sample size, the less uncertainty. Potential problems are incomplete sampling frames. We do not have a list of the whole population, so that's a problem. Might be a problem, and it's non-response, because when we draw a sample from the sampling frame, then we will end up with a gross sample. But you might not, if you call people to ask them to call everyone in the gross sample, or you send a questionnaire to all in the gross sample, well, it might be people that you don't reach. So that will be a non-response, and some people will choose not to respond. So you will lose quite a lot of your units going from the gross sample to the net sample, and hopefully your net sample will still be representative for the population. So you can do this generalization. You can say that, okay, the trust level in Norway is this and that, and the trust level in Kenya is this and that, because we have a net sample which is representative for the population of Norway and Kenya as a whole. So probability sampling methods. We have something called simple random sampling, which is based on a random selection from the list of all units in the population, for example by lottery. And the list of all units in the population is not processed in any way before the selection begins. For example, we don't order the list alphabetically or do a similar systematization of the list. And the selection of units is completely independent of a selection of another unit. That is, the units are selected completely at random. And the likelihood of a particular unit being selected from the list of units is similar to the likelihood of another unit being selected. So the likelihood is similar for all units. And if there are 100,000 units in the population, and there should be 10,000 in the sample, the probability of a specific unit being included is 10,000 divided by 100,000, which is 0.1 proportions, or 10%. And the probability, that is the probability of being included in the sample, is calculated by small n over large N, where small n is the number of units in the sample and large N is the number of units in the population. And you have also something called simple random systematic sampling. Then the units in the sampling frame are arranged in a certain order before the selection begins, for example, alphabetically. If there are 100,000 units in the population and it's decided that 9% will be included in the selection, that will be each 11th unit will be selected. Then we choose a random starting point. In our example, the starting point will be between 1 and 11, and then we select units with a fixed distance, and in our example every 11th unit will be a part of our sample. Is the starting unit, if the starting unit is unit number 3, the next unit is number 14, then number 25, number 36, and number 47, and so forth and so forth. And the distance between the units are large n over little n, where n is the number of units in the population and little n is the number of units in the sample. And the likelihood for a particular unit being selected from the list of units is similar to the likelihood of another unit being selected. So the likelihood is similar for all units. And the probability is, as with simple random sampling, it's little n over large n, where large n is the number of all units in the population and little n is the number of units in the sample. And then you have this stratified random sampling, where units in the sampling frame are grouped into different categories or strata based on their values on one or more variables, the so-called stratification variables. For example, by gender, men and women are divided into 2 stratas, or age groups, 0 to 30, 31 to 60, 61 to 90, 90 plus, are divided into 4 stratas. And if we choose to use both sex and the 4 age groups as stratification variables, we will get 8 stratas. And the stratification provides the researcher with control over the number of units that comes from each stratum. And we can do a proportional stratified selection. That is, the numerical ratio of the units drawn to each stratum is in the sample correspond exactly to the numerical relationship in the population. For example, the strata for women and men are as large in the population, 50-50. The strata for women and men should be just as large in the sample. And you can also have something called disproportional stratified selection, and that is it's useful if you want to secure an adequate number of units with a particular property. So you want to secure that you have people from a given village, for example, in your sample. And this can be illustrated like this. Simple random or systematic sampling, you have the whole population and you draw a simple random or systematic from that population, or you divide the population according to different stratas, and then you select within each strata to your sample. You have also something called cluster sampling, and that's when the units to be investigated are not selected directly, but based on a list of clusters or groupings of units. And these clusters are often geographical areas, such as municipalities or regions. And after setting up your sampling frame based on clusters, a selection of clusters based on simple random, you do a selection of clusters based on simple random or systematic selection, which are then included in the sample. And you can either investigate all the units in these clusters, one-step selection, or make a selection of units from the selected clusters. That's called two-step selection. And that can be illustrated like this. You do a one-step selection. You randomly choose a number of clusters, and then you investigate all the units in these clusters, or you draw a random sample of clusters, and then again from these clusters you draw some units which you include in your study, and that's a two-step selection. Well, that was the e-lecture about sampling. Thank you so much.